Hello everyone, my name is Naufal zhorif Taufiqurrahman. My student number is 2504040008. Welcome to my learning video. Today, I'm going to present an interesting topic that connects local Indonesian culture with physics concepts. The title of my learning video is Sop Balungan from Demak and its relationship with physics, law, and concepts. Before we begin, let me ask you something, guys. Have you ever eaten a warm bowl of sop balungan? Or maybe you've seen it being cooked at a traditional food stall? You might think it is just cooking, right? But actually, the process behind it is full of physics principles that we often study in the class. So, today, we're going to explore how everyday activities like cooking traditional food are deeply connected to scientific laws. Sop balungan is a well-known traditional dish from Demak, Central Java. Balungan literally means bones, especially beef bones rich in marrow. This soup is famous for its strong flavor, simple ingredients, and warm broth. Typically, it is made using beef bones, water, spices such as garlic, shallot, pepper, vegetable, and slowly cooking over heat. It is usually sold at night in Demak and is part of the culinary culture that reflects togetherness, warmth, and simplicity. But behind the delicious dish, there are several physics mechanisms happening inside the pot. The cooking of sop balungan involves many physics concepts. There is heat transfer, conduction, convection, radiation, Bernoulli's principle in boiling bubble, pressure and temperature relation using Cayley-Lusak's laws, the principle of density and buoyancy, fast change, it means liquid to gas, and thermal equilibrium. Next, I will explain each concept and show how they appear during the cooking process. Maybe I make some part. First, heat transfer. This is a conduction. When the pot is placed on the stove, heat from the fire moves through the metal pot. Metal is a good heat conductor, so the heat spreads quickly the water and bonds. This is conduction. Heat transfer through direct contact. Next is convection. When the water heats up, hot water becomes less dense and rises to the top. Cooler water moves down. This creates a convection current which circulates the heat through the pot. This convection is what allows the soup to cook evenly, softening the bones and extracting the marrow. Next, radiation. The flame from the stove emits thermal radiation which transfers energy to the pot even without direct contact. In summary, all three forms of heat transfer work together to cook sop balungan efficiently. Boiling and bubble formation. When the soup reaches boiling temperature, you see bubble rising. This happens because first, water at the bottom gets hot first. 2. The molecules gain kinetic energy. Third, vapor bubbles form, and rise. This connects to Bernoulli's principle, where pressure inside the bubble is lower and allow it to expand. The bubbling of the soup is actually an example of fluid dynamics in action, pressure and temperature. Cooking in an open pot means the pressure is relatively constant, the same as at atmospheric pressure. Because of Gay-Lussac's law, this is when pressure is constant, increasing temperature, increasing the kinetic energy of molecules. This is why water boils at around 100 Celsius under normal pressures. If the cook use a pressure cooker, or maybe optional, the physics change. Higher pressure increase the boiling point, making the bones soft faster. Density and buoyancy. When the soup boils, oil from bone marrow floats because its density is lower than water. Vegetable and spices float or sink depending on their density. This is Archimedes' principle, the same principle used in ships and submarines, but here we see it inside a cooking pot. Past change. Water absorbs heat until it reaches boiling point. At this moment, water undergoes a phase change from liquid to gas. This process requires latent heat, and that's why the temperature stays constant during boiling even though heat is still being added. Thermal equilibrium. When the soup is done and removed from the stove, it slowly cools down. Thermal equilibrium happens when the hot soups and the cooler surrounding reach the same temperature. This is why the soup becomes warm over time, not instantly cold. Beyond the physics, Sop Balungan represents the simplicity of Demak's culinary tradition, community bonding during night gatherings, a food that reflects local wisdom in cooking and resource efficiently. So, physics is not only explain the cooking process, but also help us appreciate the science inside daily cultural activity. Sop Balungan from Demak is not just a delicious traditional food. Its preparation process demonstrates many physics concepts, including there are many heat transfer, fluid dynamics, pressure and temperature, and density and buoyancy. That last are phase change and thermal equilibrium. By understanding these concepts, we can see how science is embedded in the culture we experience every day. Thank you very much for watching and listening to my learning video. I hope this video helps you understand how traditional culture and physics can be connected in a meaningful and fun way. I am Naufal Taufiqurrahman. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.